or down like a frown, they may be hanging a right or hanging a left. Okay? And that's the stuff we're going to look at next week a little bit more. So what we're going to do today is go back to the old-fashioned way of talking about things. The old-fashioned way of graphing. When you have a quadratic function, do we all agree that it looks like this? Y equals ax squared plus bx plus c. We've talked about that in the past. Do we all agree on that? If your a value is positive, what direction is your curve? It's up like a cup. So if a is positive, we know it's up like a cup. If a is negative, we know it's down like a frown. We all agree on that, right? Mm-hmm. We also know from working with discriminants the number and the types of solutions you can have. If your discriminant, your b squared minus 4ac, if that was positive, we had 2 real. If it was negative, we had 2 imaginary. And if it was equal to 0, we had 1. What that basically told you was where your curve might be placed. Okay? That's kind of where that went. Well, what we're going to do today is go right into a very easy way of graphing. And I like to start with what they call the standard form. Standard form is just your ax squared bx plus c. So let me show you an example of what you do. Oops, one button. I'm not worrying about graph paper. In here, there will be times that we will use the graph paper, and there will be times that we don't. A lot of times when we start these things up, I like to be a very, I want to say visual, but it's not the word I'm looking for. A very basic idea of what is happening. Well, when I have a quadratic graph, the first thing I'm always going to do is find what's called axis of symmetry. Remember that?
Yes.
We talked about it. It's the halfway point between all the points that are on the parabola itself. And how you do that is now your axis of symmetry. These graphs are either going to be up like a cup or down like a frown, which means that the axis of symmetry would have to go like that. Do you agree? When you have a vertical line, what does the graph of every single vertical line start with? 0. Right. What is the graph of every single vertical line have? X equals. Very good. A vertical line is always x equals a number. So our axis of symmetry is always going to be x equals, well, how you figure that out from your quadratic equation, your standard form, is always going to be the opposite of b over 2a. What we're doing here is we're plucking coefficients off. Okay? We're plucking coefficients. So the first thing that I do when I have a standard form of an equation, I'm going to find the axis of symmetry. In this case, it's going to be x equals, what's the opposite of negative 8? 8 over 2 times 2, otherwise known as, which is 2. So I know that if I rough sketch a graph, I will have a vertical line through what? 2. My axis of symmetry lies at 2. No, what's the opposite of a negative 8?
Negative 8 is 8.
Right, so
Isn't the bottom negative? So this is it's a positive.
yeah. Now, when I'm looking at this, remember when we talked about our graphing, when we talked about word problems, what did we know that happens at the maximum or the minimum? Remember, that's your maximum and your vertex. It curves there, okay. Now, we know that this is going to be up like a cup, right?
Yeah.
We know that this, remember when we did our, what was it, our word problem where we went like this? this value was your x coordinate. Remember I told you that that was that axis of symmetry? The x coordinate is the axis of symmetry is the x value. That will always be the coordinate of your vertex. So if I take the number 2 and I substitute in, what do you think it's going to give me? It's giving me the y value. It's going to tell me what my vertex is. So I get 2 squared times 2 is 8. 8 minus 16 is negative 8. Negative 8 plus 6 is negative 2. So that tells me now that first thing I did is I found my axis of symmetry. The next thing I do is I get my vertex. And I know it's going to be at, well, 2 and negative 2. Everybody okay with that? From there, we're going to use, since we're doing rough sketches today, we're going to use some very easy numbers to plot sets of points. What is the easiest number to substitute into that equation to figure out a y value?
1.
0. Because what's 0 squared?
0.
What's 0 times 2?
0.
What's 8 times 0?
0.
What's 0 minus 0?
0.
What's 0 plus 6?
6.
So at 0, I know it's at 6. Everybody with me on that?
Yes.
How far away is 0 from the axis of symmetry?
2.
So what's 2 more spots to the right of it?
4.
And what do you think that value will be?
6.
There's your curve.
Is that all we have to do?
Yeah. I'm looking at rough sketches right now. Very confused. Okay. When we did here, were you okay getting the vertex? Okay. The axis of symmetry always goes through the vertex of a parabola, whether it's up like a cup or down like a front. Always, always, always. Since this is going to be up like a cup, the axis of symmetry is x equals some number. Therefore, that x value is the x value of the vertex. To figure out what the y value is, all we're doing is direct substitution here, because this x generates the y.
And then that whole equation.
Not the whole equation equals, oh, this part here, when I substitute, yes, that equals negative 2.
So that's the y.
Yeah. So when x is 2, y is negative 2. I was just using substitution to figure that out. From there, I was thinking of a very easy point to figure out. Because remember, this is the kind of stuff I'm going to have you guys do without a calculator. So the easiest point to pick on is 0. Because if x is 0, I get 0 minus 0 plus 6. So that's why it's at 0 and 6. And 0 is how far away from the axis of symmetry. So if I go 2 more to this way, it would be at 4 and 6. Because remember, parabolas are symmetrical. That's why that works.
Mr. Mayor, I don't understand the second part of that. I understand how you got the.
How far away is 0 from 2? Then go the other way. What's 2 more than 2? I'm looking for what's called the symmetric twin. So our ordered pairs here, if I'm looking at it, I've got my vertex at 2, negative 2. One set of ordered pair over here was at 0 and 6. And the symmetric twin was at 4 and 6. That's what I'm looking at doing. It's a very easy way to go through it. Okay. Now, I know there are many, many ways to graph off of standard form. I think that for all intents and purposes with us, when we have a standard form equation, this is the best way to go. You're showing me the axis of symmetry. You told me what it was, x equals 2. You told me the vertex, and you gave me a pair of symmetric twins. We call it a day. All right? Not so bad? All right. Let's look at another one. Is that it? The other form that we're going to look at today, we actually have 2 others, but we'll start with just what's called the vertex form. So we have standard form, move this up. Vertex form is your introduction to H's and K's.
Oh, yeah.
So we have standard. What's nice about vertex form, your vertex form tells you where your vertex is right away. It tells you your vertex is at the ordered pair of H and K. Now, what I want you to see here, and I'll pull this up with a real equation in 1 second. Notice how it says X minus H? So if I had an example where it was, let's say, 2 times the quantity X minus 2 squared minus 3, the ordered pair for my vertex would be at positive 2, negative 3.
What? Oh, I get it.
Because you're taking just the value of H right here.
Oh.
Okay. It's very similar to when you guys did point slope form last year. Y minus Y sub 1. Did you know that was nothing more than H and K with not using H's and K's? Point slope form. That's H and K. Your X value is your horizontal shift. Your K value is your vertical shift. Vertical. I know it's a C.
That's right.
It's a tough crowd. Tough crowd today. So if I have an example, let's use that one. Y equals 2, X minus 3, quantity squared plus 2. And I want to do a rough sketch of what that looks like. Right off the bat, when it's in vertex form, I can label out what my vertex is. So that's what we do. My vertex is going to lie at 3 and 2. Everybody okay with that?
Yes.
Because that's now here, if my vertex is at 3 and 2, what's the equation for your axis of symmetry?
X equals 2, 3.
X equals 3. Because what's the x coordinate? 3. Your axis of symmetry is the x coordinate. Okay? Once you have your vertex, the x coordinate of that is your axis of symmetry every single time. All right. So let's take a look at what that looks like. Throw in a little grid. I know my vertex is at 3, 2. Let me ask you this. Is this one going to open up or down? What do you think? Up.
Because A is...
A is positive. In this case here, again, you notice how the 2 value is positive? So this one's not going to have any zeros, or it might have imaginary zeros, which we're not really worried about here. Yes, ma'am? I thought you were about to kind of just over your hair. All right. We know that this is going to be, it's going to go up like a cup. I know that my axis of symmetry is a vertical line through 3. Okay. I know that occurs. So once again, I'm going to try and figure out some very easy value to substitute in. Now, if I chose 0, if I chose 0 again, what's 0 minus 3? What's negative 3 squared? What's 9 times 2? Plus 2.
So it pretty much always sub in 0. It's always gonna be
You can pick whatever number you want. Sometimes some numbers are easier to use than others. Sometimes, depending upon the way it's written out, it's just a lot of little mental math. 0, I always thought was easy. Okay. Now, here's the nice thing. How far away was 0 from the axis of symmetry?
3.
So what's 3 more to the other direction?
6.
So what do you think that's going to be at?
20.
So- What's 0 minus 3? What's negative 3 squared? What's 9 times 2? What's 18 plus 2? So when you have substitute in 0, you get? Okay. That's what we're setting up here. So now I have I know where my curve is going. I have my 2 sets of ordered pairs, my symmetric twins, and I've labeled out vertex and axis of symmetry. 0, 20, and 6 and 20. Not bad, is it?
Yeah.
Notice how we're doing this without a calculator, by just doing a couple very simplistic steps. Okay? And then yes, ma'am. It's just an ordered pair. I know you want to call it a y-intercept, but you don't really need to worry about y-intercepts. These 2 points are just symmetric twins. That's all they are. Could you have used 1 or 2 or anything in there? Absolutely. It would have worked just the same. I like to just use something that's a little bit, I like using 0 because it gives you a better idea of how wide or how narrow your graphs are, depending on where your axis of symmetry is. Now, if my vertex was all the way over here at 10, using 0 might give me an ungodly number. I might want to use 9 or 8. But as you start to play around with some of these things, you'll see how it's pretty easy to work with. All right? And then the last form is another form that we've actually worked with. You just didn't know you were working with it. It's called intercept form. The intercept form is y equals a x minus h, y minus k.
What's P?
Oh, p and q. I'm sorry, they use p and q. I forgot to use p and q. I do that every year. Where p and q are the zeros. Thank you. I'm batting 1,000. Or run away. Okay. Now, we've graphed with that before. Remember when we did our word problem functions, our revenue functions? We found our zeros, placed them on the graph, drew our curve, whether it was going to be up like a cup or down like a frown, and therefore we found our axis of symmetry, because what happens at the axis of symmetry for your zeros? It is located where? In the middle. It's halfway between it. Now, what's nice here is that you've done that. You know if A is positive, it's opening up. If A is negative, it's opening downward.
Right.
You've done that. Okay? The only part that's a little bit different from what you guys worked on is that that value of A has been factored out. If you think about some of the problems that we've done with the word problems, we've left our terms larger on the inside, where you had the 30 minus 2x. You could have factored out a 2. We just didn't. Okay? It's not a big deal that we did it because it was easier for us. So let me show you how that works. Okay. I don't know why I use that. I'm not going to use graphs. So I have I'm going to graph it using that. I forgot to delete out that other bit. There's other weird things here, but I don't. We've already done this, so don't worry about the Simpsons thing. We have y.
Put it there.
I used it last year, and I taught it differently this year, so it had some steps, so I'm not really worried about it. I was hiding something.
Oh.
So pay no attention to the thing behind the glass. In this case here, we have y equals negative, so negative 1 times the quantity, x plus 2, x minus 4. Very similar, yeah. Because now, if I look at this, where are my zeros? Negative 2 and 4.
But you're adding get the equation original form.
Yeah, because what you're doing here is you're setting these, you're finding zeros. What are your zeros?
Oh, you find the zero, and
Yep.
that's the zero.
Yep.
Okay.
Yeah, your zeros are those through. Okay, it's always just a straight opposite sign. Now, what happens at the halfway point between -2 and 4? The axis of symmetry. So what's -2 plus 4? What's after that? 1. See how easy that is? We know where our axis of symmetry is going to be located halfway between them. So our axis of symmetry is at x equals 1. Now, I need to find my vertex. I know that my axis of symmetry is at x equals 1. So if it's at x equals 1, that means my vertex is going to have an x coordinate of what? 1. So here's what we have to do. What's 1 plus 2?
3.
So we have -1 times 3. And then what's 1 minus 4?
3.
What's 1 plus 3? I'm sorry, you're right. What's 1 plus 2?
Oh, I was like, 3.
Yeah, I'm sorry, I looked at the 3. All I'm doing here, guys, is I'm taking the x coordinate, because that's our axis of symmetry, and I'm just substituting it in here to figure out what the y value is.
I don't know.
Okay.
Why is there a negative sign in front of it?
Well, what's the number in front here that you don't see? It's a -1. That's why I just rewrote it as -1 times 1 plus 2, 1 minus 4. Okay?
So wait. So y.
Y equals 9. So that my vertex is at 1 and 9. And since the a value is negative, which direction is it going? Downward. There's a little bit less work involved when you're given zeros. Yes, I know. Yeah, I know. I wanted to get that in. I just wanted to finish that one out. There's a lot less work given to you when you have zeros right off the bat. It's a little bit easier to graph because you don't have to find that extra set of ordered pairs. They give it to you. What I want you guys to try over the weekend is I'm going to give you a couple of each style to graph. This is on section 5.1. I'd like you to do numbers 20, and I don't want you to use graph paper. I want you to do it how we did, okay? 23 to 25.
Number, you was in your computer.
Oh, page 53.
Does that matter? 15.
I'm just giving you 3 of each style.
Oh, okay.
I know. I'm giving you 9 of them. 3 of each style to try. There is a little bit more algebra that we're going to work on later on next week with these, and we'll show you how that all works later. All right, we can work. All right. Remember, hey guys, real fast. Remember when you're graphing these things, make sure you say where your vertex is, what's your axis of symmetry, and a set of your symmetric twins. When you're graphing it, they're giving you your zeros, when they give you intercept form, you really only have to do your vertex and your axis of symmetry because your zeros are your symmetric twins. Does that make sense?
Yeah.
Intercept form is always a little bit easier. Okay? They'll make this weird next week. Yay! Yes, ma'am.
I have this for like forever.